What's up, dudes? Today we're going to solve problem 1 sent to us by dailycodingproblem.com. Good morning. Here's your coding interview problem for today. This problem was recently asked by Google. Given a list of numbers and a number k, return whether any two numbers from the list add up to k. For example, given 10, 15, 3, 7, and k of 17, return true since 10 plus 7 is 17. Bonus, can you do this in one pass? Okay, let's read this carefully and make sure we understand what is being asked of us. We are given a list of numbers and a number k. We need to write a program that determines whether there are any two numbers from this list that added together will equal k. So in this example, k is 17. From our list we have 10 and 7, which added together equals 17, so we would return true. If k was 19, we would return false, since there are no two numbers from this list that added together will equal 19. And note we're returning a Boolean value here. Seems simple enough, but how do we write a program that does this, and how do we do it in one pass? Well, to do this in one pass, what we're going to do is we'll create a hash set. We will then do one single iteration or one pass through our list here. Along the way, we'll subtract I from k. We'll check to see if the difference between I and k is in our hash set. If it is, we return true. Otherwise, we add I to the hash set. Now, I said a lot of words there, and if it sounds confusing, don't worry. We're going to type this up in notes, and then once we code it up for real, I'm going to go through it slow. So let's start writing the notes for this. So the first thing we need to do is create a hash set. Next, we're just going to do one single iteration through our list here. And during that iteration, we're going to subtract I from k. Next, we're going to check to see if the difference is contained in our hash set. So, say if the set contains the difference, we return true. Otherwise, we need to add I to our hash set. Now, whenever you're presented with a problem like this, I recommend typing up notes for your solution before you actually start writing code for it. And I think we have enough now to go off of. We'll use these notes as a guide. So let's start coding this for real. I would also recommend when you're doing this on your own to use a blank IDE or blank text editor like we're doing right here. So we'll give ourselves a constructor for this. This is where we will set up our test. And we'll give the solution its own method. So let's create the variables that we'll be using. We'll use an array for a list. And we'll just give it the same values that are in the example given to us. Alright, and k will be 17. And then to test this, we will just print out a call to our solution method and see if it prints what we expect it to print. So we'll need to pass in our list and k, and so we'll add those parameters here. Alright, so let's use our notes as a guide here. The first thing we need to do is create our hash set. And we'll be storing integers. We'll call it set. Now, if you don't know what a hash set is, to explain it in detail is really beyond the scope of this tutorial. The important thing you need to know is that it stores values based on their hash code. So what Java does under the hood is it applies a hash function to the value that we want to store, which will be an integer. That in turn produces a hash code. Now you can look at this hash code as an address. So it is then stored at that address. It stores that value at that address in the hash set. And why that's important is because it allows us to look up values very quickly. Alright, moving on. Next we need to do a single iteration through our list. Okay, and we need to subtract I from k as we go. So let's give this its own value. Okay. Now we need to check to see if our set contains the difference. So we're using these notes as a guide, and we're at this point right here in our notes. And we'll come back and talk about this contains method a little bit more toward the end. So if it does contain that, we need to return true. Otherwise, we need to add I to our set. Okay, so we accomplished everything that's in the notes here. If we never return true, then of course we need to return false. And I think this will work. So let's just go ahead and talk through what an iteration or what a pass of this is going to look like. So to do that, I'm going to copy these values here and put them right next to the for loop, just so hopefully that will make it more clear. No, not that. And let's denote our value for k here as well. Okay, so let's walk through this. The first I is going to be 10. So diff will equal k minus I, so 17 minus 10, so diff will equal 7. So we check, does our set contain 7? Well, no it doesn't. Our set is completely empty, so we need to go ahead and add I to our set. So let's keep track of what our current set is right here. And note that we're adding I. We're not adding diff to our set. Next, I is 15. So diff is 17 minus 15, so diff is 2. Does our set contain 2? No, our set only contains 10. So we need to add 15 to our set. I is now 3. Alright, so diff is 17 minus 3, so diff is 14. Does our set contain 14? No, our set only contains 10 and 15. So we need to add 3 to our set. Now I is 7. So diff is 17 minus 7, so diff is 10. Does our set contain 10? Well, sure enough it does. That's the very first value that we added to our set. So we would go ahead and return true at this point. Alright, I think that's going to work. Let's go ahead and print out our set right here to string, just so we can see it print in the console. And let's test this thing out, see if it works. So we have this set up in an object-oriented way here. We will instantiate our problem class, at which point our variables will be created. We'll make a call to the system.outPrintLine method, which will invoke our solution method, and we should see true return right here. So when this runs, we should get to see 10, 15, and 3 printed out. Not necessarily in this order, though. And then the solution should be true. So let's see if that's what happens. Okay, and it looks like it. So an important note here is this printed out, you'll see this printed out 3, 10, 15. But the values in the original list are actually in this order, 10, 15, 3. I know this looks like it was sorted or something like that, but it wasn't. Sets are unordered, so this just printed out this way by coincidence. We could run it again and it might print out in totally different order. So remember that about sets. They are not in any kind of order. Alright, and let's just test a different value for k. So we'll give it 19. And in this case it should return false. And every value from our list should be printed out. So this time we'll never reach this point in our program. We will add every I to our set, which in turn will print out these 4 values, not necessarily in this order. So let's test that real quick and see if it works. And that is what we expect. Again, this is not sorted. This is just coincidence. It's being printed out in this order. Okay, now let's talk about the time complexity of this. So I mentioned I was going to go over this contains method. And the important thing to know about this contains method is that it works in constant time, which can be denoted as big O of a constant. We'll use 1 in this case. Now the way this contains method works is the set checks to see if diff is contained within the set by applying that same Java hash function to diff, to the value that we pass in here, which then produces the hash code for this value, or look at that hash code as an address, like I was saying earlier, and it checks to see if this value is at that address within the hash set. If it is, it returns true, otherwise it returns false. That's how it's able to check to see if it contains value so quickly, because it doesn't have to iterate through every value in the set. It only has to check this one address to see if this value is here. It doesn't matter if there's one element or a billion elements. It still works in the same amount of time, assuming there's not collision and things like that. But that's not really for this tutorial. That's we're not going to get into all that here. What you need to know is that it works in constant time. All right. Next, the time complexity of our overall program here is going to be, you could probably guess this, big O of n. The time complexity of this overall is big O of n, and that's because in the worst case scenario, we're going to have to iterate through this entire list, so we'll have to touch every value in this list. And I think that's it. If you have any questions, leave them in the comments. Otherwise, I'll be doing problem number 2 next, so be on the lookout for that. Stay hard, guys.